In this video, we're going to do the last part of limits of accuracy, and we're going to focus on practical examples. You will find this on page 31 in the Namibia Mathematics Ordinary Level textbook, Y equals mx plus c to success. Let's look at an example. Calculate the upper and the lower bounds for the perimeter of the rectangle. Show if its dimensions are accurate to 2 decimal places. Now, 2 decimal places, 1, 2, 1, 2, it's always 0.1 that you divide by 2, and this is the value that you will add or subtract. Then always first, get first the upper and the lower. So remember, this is the lower bound. I take that value, 4.84, and I subtract this. Then I take that value and I add this, and this is the upper bound. And this is the lower bound, and this is the upper bound. Okay, and then I'm going to start. So the perimeter is 2 length plus 2 breadth. Now, if I'm going to look at this, so if I'm going to say, okay, it's just addition. So to get the smallest possible, it's lower plus lower, but just 2 times each. And to get the biggest, it's upper plus upper, and 2 times each, because there's 2 sides that's exactly the same. And then I just press it in, and this will be my lower bound. Ooh. Just putting that extra lines away. This will be my lower bound, and this will be my upper bound. Okay, I want you to stop the video, and I want you to do number 1, which is more or less exactly the same. And then you can also do number 4. You can continue the video as soon as you are finished. Okay, let's do number 1. Calculate the upper and the lower bounds for the perimeter of the rectangle shown if its dimensions are accurate to 2 decimal places. Almost exactly the same. So it's 0.01 divide 2, and that will be 0.005. So now I have my 2 dimensions, and I'm going to make it a bit more visual to you. Okay, oh, sorry, this line is not nice. Oh, it's too big. Okay, let's try again. Straight line. Okay, this is better. It's just a rough sketch. Okay, so what was the 2 values? The 2 values was 6.82. and 4.24. So if I want to find this one, the upper, the lower, the upper, the lower. So basically, I'm just going to add for this upper and subtract for the lower. So if I'm going to, so for the upper, I'm going to find it as 6.825, and the lower is 6.815. And then this one, the upper, is going to be 4, and I'm just going to move it a little bit, 4.245, and the lower is going to be 4.235. Okay, and now I'm just going to do the calculation. Remember, it's perimeter. So perimeter, now let's just do it like this. So it's the perimeter. So again, so it will be 2 length plus 2 breadth, 2 length plus 2 breadth. And because it's addition, so it's going to be 2, remember this is lower bound, plus 2, the lower bound, the smallest. And this is going to be 2 upper plus 2 upper. Okay. And then I'm just going to substitute it. So the 2, and then I'm just going to look for the lower bounds. So in this case, I'm going to start with this one, so it's 6.815 plus 2, and then the lower bounds for this one is 4.235. And then remember that this is the perimeter, so it's 2, and then the upper bounds for this one is going to be 6.825, and the upper bound for this one is going to be 4.23. I don't know. Sorry, I'm writing it incorrect there. Let's just make it correct. 4.245. There was the 3.5. And then if I do that calculation, I'm just going to get 22.1 and 22.14. So then the lower bound will be 22.1 and the upper bound will be 22.14, and that is all in meters. Okay, let's just make space and let's just do number 4. Calculate the upper and the lower bounds for the length mark X in the rectangle. The area and the length are both accurate to one significant figure. Okay, now again, I think I'm going to start again with my figure. Length mark X in the rectangle. It's a rectangle. So remember the area and that is going to be 100, and then one of the sides is going to be 10, and then again I'm going to find my upper bound and my lower bound, and my upper bound and my lower bound. Okay, now it's very important that you see this, are both to one significant figure. Now there's the 1 and there's the 1. They put a 1 in that place and there is 0. So it's actually 10 divided 2. And there's a 1 and there is 0, so it's 100 divided 2. So actually I will add and subtract 5, see with the bottom one, and this 50. So if I look at this upper bound, so let's just go for the upper bound here. So this is going to be then 10 plus 5. So this is going to be 15. This is 10 minus 5 and it's going to be 5. This one, 100 plus 50, it's 150. And 100 minus 50 is just going to be 50. Okay. And then I'm going to start and I'm going to say, okay, the area. Now this is the area, this is, don't forget the area of a rectangle. Let me just write it here. Is length times breadth. So if I say, for example, want the breadth, it's just the area divided by the length. That's all. So it's a division. So if I want to get that calculation, so let's call it X. Oh, sorry, let's just get that sign correct for that division. So basically, remember it's division. So if it will be lower bound divide upper bound. Go back to that table if you struggle with this. And this one will be upper bound divide lower bound. And actually, it's every time, don't forget the original calculation. It's just 100 divided by 10. So this is the calculation. But now, what is the lower bound of 100? So the lower bound of 100 is 50. What is the upper bound of, oh, it's 10. What is the upper bound? 15. Okay. And then, what is the upper bound of it's 150. What is the lower bound? It's 5. And by doing that calculation, I get 3.3, just get the pen correct, 3 and x, and this one 30. So the area of the length, calculate the upper, so therefore the lower bound is 3.333 and the upper bound is 30. And that's how you do it. Okay, let's look at the last practical one. I'm going to look at this example. The equal sides of our isosceles triangle are each 7.7. Can you see there? Correct, and this is correct to the nearest millimeter. So there's a 1 if there's nothing. The perimeter is this. This is the perimeter. Also correct to the nearest milliliter. Calculate the smallest possible length of the third side of the triangle. Now, don't forget, if I want perimeter, it's just actually going to be side plus side plus side. But these sides are the same, so it's almost like 2 of these sides plus this side. So the perimeter is side plus side plus side. So if I want the third side, I will just say the third side, it's the perimeter minus that side minus that side. Okay, so but now don't forget this is okay, if I put it in brackets, it's an addition. Do you see? That's what I did there. So for subtraction, it will be lower minus upper. But because this is addition, and I want to put it in. So this for subtraction, it will be lower minus upper. But because this is inside of this bracket is addition, and the addition is upper plus upper. So first just get your uppers and lowers in order. And then take the individual sides, find the upper, lower, upper, lower, upper, lower, because it's to the nearest 1 millimeter, but this is in centimeter. So take the millimeter to centimeter, it's 0.1, and then I divide it by 2. So add and subtract this value. Okay. It's a bit rough. Okay, and then I just get my answer. Okay, and then I'm going to start with this one. I think we can do this, yeah, I think let's keep to the triangles. Here's another triangle one. I want you to stop the video and I want you to do number 2. You can continue the video as soon as you are finished. So, let's start. An equilateral triangle has sides of length 5.1 centimeter, correct to 1 decimal point. Okay, it's an equilateral. Calculate the upper and the lower bounds for the perimeter of this triangle. So this is actually a nice one because that is not really going to be so complicated. So it's try now 26 and it's number 2. Okay. So correct to 1 decimal, it's an equilateral triangle. Can I just show you here? So that means all the sides are equal. Okay, so if I look here, equilateral triangle, sides 5,1. Correct to 1 decimal place. Don't forget 1 decimal place, but you know 1 decimal place is easy. It's always 0.1 divided 2. So I will add and subtract 0.05. So if I already want, and I think I'm going to write it, this is the upper bound, this is the lower bound. So what will my upper bound be in this case? It's going to be 5.15. And what is going to be my lower bound in this case? It's going to be, okay, let's just write it down. This is going to be 5.05. Okay, and now if I look at the perimeter of 3 sides, okay, let's just see, calculate the upper lowers for the perimeter of the rectangle. So the perimeter is actually it's just 3 times the sides. So if I want the lowest possible answer, the lower bound, it's just going to be 3 times the lower bound, which is going to be 3 times 5.05. And if I want the upper bound, it's just going to be 3 times the upper bound, which is 3 times 5.15. And this answer is going to be 15.15, and this answer is going to be 15.45. Calculate the upper and the lower bounds. I think I want you to end with a last one before I stop this video, because this is actually a very interesting one, and that is number 3. So stop the video, try number 3, and as soon as you are finished, you can continue the video. Okay. So the mass of 60 oranges is given as 42 kilogram. Correct to 2 significant figures. Okay, this is very important. You have 60 oranges and you have 42 kilogram. Now, remember, you cannot find the upper and the lower bound of the oranges because that's fixed, that's 60. But you can find the upper and the lower bound of the kilogram. Okay, and that's to 2 significant. So 1, 2. So put a 1 there, 3 zeros. So it's actually going to be 1 divide, let's just put it there. 1 divide 2, and that's 0.5. So for my upper bound, this is my lower bound. So my upper bound is 42.5. And my lower bound is 41.5. Okay, that's my upper and lower bounds. Now, calculate the lower upper for the average. Now, how do you find the average in this case? You're just going to take the kilogram and you're going to divide it by the amount of oranges. But now remember, this one is fixed. It's not having an upper and lower. So if I'm going to find the lower bound, let's just get that correct. Then it's going to be just the lower bound, and I'm going to just divide it by the amount of oranges, 60. And if I want to find the upper bound, I'm just going to take the upper bound and I divide by 60. So the lower bound, let's just see, the lower bound is 41.5 divide 60. And in this case, the upper bound is going to be 42.5 divide 60. And that is going to give me an answer. So this is going to be 0.692 kilogram, this pen per orange. Okay, and then this upper bound is 0.708 kilogram per orange. I just want to highlight again that orange is not coming out. Remember, if it's a fixed amount, like a number of something, people, oranges, item, you cannot find the upper and the lower bounds. You keep it fixed.